All right, this screencast is on identifying the types of chemical equations. There's actually 5 that we're going to focus on in chemistry, and they have some pretty easy ways to look at them and figure out what type they are. So what we're going to do is we're going to look at each one of them, give the name, the identifying characteristics, and a sample equation that you can look at. All right, the first one looks like this. It's called synthesis or combination. And it will look like something plus something makes a combination of those two things. So if we're looking at it in dances, it's Jack plus Jill makes Jack and Jill, who are now a couple. So let's look at the identifier choices. So of the 5 identifier choices listed here, what we just looked at for synthesis and combination, we would have our identifier choice would be one product only. Okay, so you would see one product only. And if we're looking at an actual chemical equation of these 5 choices, the one that is the synthesis equation is this third one here. So N2 plus 3H2 makes 2NH3. All right. All right, the second equation type is called decomposition, and this is the opposite of the synthesis and or combustion or combination. So decomposition is where you have one thing breaking down into parts. So we have the Jack-Jill couple breaking up into Jack and then Jill separately. So this is called decomposition. So let's look at the identifiers. So of these identifiers, now remember we've already used the one product only. The remaining ones, this one is decomposition is one reactant only. Okay, and so let's go back and look at the equation choices and identify which of these remaining 4 would be a decomposition. And the decomposition is the number 2 equation here. So 2KClO3 yields 2KCl plus 3O2. The third type of equation is where you have a compound, like John and Jane as a couple, and a single element like Mike makes Mike and Jane a new compound and John a separate single element. So this one is called single displacement or single replacement. It depends on which book you're looking at. Both are accurate, both are acceptable. Single is the important part, single replacement or single displacement. So let's look at our identifier choices. So we've eliminated the last 2 with our first 2 elements, and this one would be one element switching in, likes replace likes. So let's go back. When you're looking at this compound, you have a John-Jane compound and Mike. The Mike has to replace the portion that it is similar to. So Mike as a male name would replace John as a male name. And so you make the Mike-Jane new combination and John. Elements do the same thing. So if you have a metal and a non-metal, if this piece would be a metal, it would replace the other metal. So let's look at the equation choices. So we have used number 2 and number 3 previously, and if you look at these again, you can see that number 1 has a compound and a single element. Even though it has a diatomic, it's a compound and a single element, forming a new compound and a new single element. So number 1 is the single displacement or single replacement. All right, the fourth equation is you have a combo or a combination here of Brian and Maggie, and you have another combination of Bob and Sue, and then you form a totally new set of 2 combinations. You have Bob and Maggie and Brian and Sue. This one is called double displacement or double replacement because both compounds have switched partners. So Brian is now with Sue and Bob is now with Maggie. It's kind of like FOIL in math, but you have to be careful in the arrangement of which part goes first, because remember in compounds you have to have the positive part first and then the negative part first, or the negative part second, excuse me. So you have 2 compounds and they've both switched. So let's go look at our identifier choices. So obviously, since I just said it, the choice number 1 says 2 compounds switching. Again, likes replace likes, just like we had with the last one with single replacement. The metal has to replace the metal and the non-metal has to replace the non-metal. So let's look at our equation choices. Of the ones that are remaining, I believe our only choices left are number 4 and number 5 here. So if you look at them, we're looking for something that has 2 compounds on both sides, and the 5th equation here is the correct one for a double displacement. So you have AgNO3, which is a compound, and you have MgCl, which is another compound, and they will switch. So you now have AgCl and you have MgNO3. Okay, so they are 2 compounds switching. All right, the last equation is a little bit more of a challenge to illustrate with a picture. It doesn't have a story that I can easily liken to another pair of people or names or something like that. This one is called combustion. And in a combustion reaction, you have products of only water, H2O, and only carbon dioxide. So you can only have specific elements involved in a combustion reaction. They have to have, your whole equation is going to have carbon, hydrogen, and oxygen, and those are the only elements you may have. Your products will only be carbon dioxide, CO2, and water, H2O. Only those things, and you must have both of those things. So let's look at our identifier choices. It should be pretty easy because we only have one choice left. So our last choice says products of CO2 and H2O. If you see an element, or I'm sorry, an equation that has CO2 and H2O as your products, and they are the only things there, it's the easy choice. It's a combustion reaction. And let's see if we can get an equation here. Looking at these equations, we have used 4 of the 5 of them. You can identify that this 4 equation here has carbon, hydrogen, and oxygen, and its products are CO2 and H2O, and only those 2 substances. So they are combustion reaction. Hopefully the equations and the examples that we've given, along with the key identifiers, will help you to look at any chemical equation and identify if it's one of these 5 types.